first thing we want to talk about this week is the distance formula. So the distance formula just basically tells us the distance between 2 points. Why is this important? Well, same idea like GPS or anything like that, where you're trying to find the distance between 2 points. How do we do it? Using their location. So the formula to do this is the square root of x2 minus x1 squared plus y2 minus y1 squared. And fun fact, it actually comes from the Pythagorean Theorem. So when you draw 2 points, boom, and you're trying to find the distance between them, we can actually turn this into a right triangle, boom, where the two legs would be A and B, and the distance that you're trying to find would be C. So if you're familiar with Pythagorean's theorem, you have a squared plus b squared equals c squared. And then you could just go ahead and square root both sides. And you can see that the length of c is going to be the square root of a squared plus b squared, which a would be, actually b in this case, would be x2 minus x1, and a would be y2 minus y1. So if you just know the length there, you can just put in a and b and solve for it. Woohoo! Kind of a fun fact. Hopefully you find that interesting. Sometimes it helps stick with the memory if you know where that formula came from. And you can connect it and actually recreate it. So let's go ahead and just find the distance between 2 points. So you start with the square root. And then just inside, you want to go ahead and go back if you need it. Subtract your x's and subtract your y's. So my x's, this would be x1, this would be x2, the first point in both of these. So it doesn't matter which one you put first. I'm going to do x2 first just to get into that habit. And then likewise, you want to stick with that same ordering that you used for the first one. So y2 minus y1, 3 minus 1. And we have to simplify the inside first. So this becomes the square root of 7 minus 3 is 4. 4 squared is going to be 16. 3 minus 1 is 2. 2 squared is 4. And then we just go ahead again, simplify by adding inside first. 16 plus 4 is 20. So we have the square root of 20, which you can break that into 5 and 4, just for fun, right? Reduce that radical, just for fun. That's what I like to do in my free time. It would be 2 times the square root of 5. Yes, 5 times 4. Okay. So you would have a distance of 2 times the square root of 5, or probably you'll want to just plug that into your calculator and just do square root of 20, or 2 times the square root of 5 is going to give you 4.47. And I rounded that to 2 decimal places. That's usually a safe amount when you're talking about distance. Now they don't tell you the units here, so we could just go ahead and write units. If it had been feet or something like that, we would use feet. But they don't tell us that, so we're not going to worry about it. Let's go ahead and try one more. This time we need to be careful of those negatives, and the negatives will come back to haunt us if we're not careful. So we always want to be careful with negatives. So again, we can label them first if we want to. You don't have to. So whatever you're comfortable with. So again, subtract x2 minus x1. Now notice there's 2 negatives there that we're going to have to take care of. Again, on the second one, y2 minus y1. And again, there's 2 negatives because you're subtracting a negative value. And easiest way to deal with this is just to, when there's 2 negatives, just change it into a plus. So they just, 2 negatives combine to make a plus. It's like a transformer or something. Whatever you need to know for that. Anyways, let's go ahead and keep going. So just inside, square root of 1 plus 6 is 7. 7 squared is 49. Negative 4 plus 8 is going to give us positive 4. Squared is 16. Go ahead and add those together. 65? Yes, square root of 65. Let's see if that's divisible by anything. I guess it doesn't matter. But let's go ahead and just plug it into our calculator to find the square root of 65, which is 8.06. 8.06 units. I'm making a mess today, hitting my hand all over the place. Okay, so that is how you use the distance formula. Go ahead and try it out a little bit. Be careful of those negatives, and you got it. I wanted to quickly show you guys how to check your work using Geogebra as well. So I have the answers right here, and I want to go ahead and just pull up Geogebra. So here is Geogebra. I downloaded the app. You can use it online. So it is a free program. It's freeware. So, and it does pretty awesome things. So one way you can check to see if you did this right is go ahead and grab the points 3, 1, and 7, 3. So there's a point tool. If you click on the point tool, go to 3, 1, click, and you've made a point. The other point was 7, 3. So then you go to 7 up to 3. So we have 2 points. Well, what you can do is you can create a line, or if you click this little down arrow next to the line, you can create a line segment. So let's go ahead. We're going to grab that line segment. Then we're going to connect these 2 points. So just click on each of those points. And notice you have a line segment. And if you look over here, it's actually going to tell you the length of that line segment, which is 4.47. Which, if we go back to our notes, what's the length that we found? 4.47. Yay. Okay, great. We checked it. Now let's do the same thing for the next 2 points. -6 and -8. So if you want to move around, because I'm kind of running out of room, just make sure you're on this cursor and then just grab the screen and drag. And then you can go back to your point just by clicking on it. So -6, -8. And then what was the other point? 1, -4. So 1, -4. Again, we're going to grab that line segment tool. Just connect those 2 points. Boom. We have a line segment. If we look up here, it is highlighted and it tells me the distance is 8.06. That means I did it correctly. Wahoo! I don't have to worry about anything else. So just an idea if you want to check yourself after you've done the calculations. Give it a try.